All right, so welcome those of you who are joining us for the recording. Yeah, so basically this week we are talking about different ways to take some derivatives. We're going through product rule, quotient rule, we talk about chain rule, we talk about derivatives of trig functions. So I'm going to kind of start this off with my little 2 cents about how kind of to approach these types of problems. And that is kind of just practice, practice, practice. Your book has a ton of problems to go through. There are a ton more online. And the best way to get good at this material is to just practice it, which I know is very time consuming and annoying, but I promise you it does get easier the more that you do problems like this. That being said, who's ready to do some practice? Does anyone have any particular questions about the material that we covered this week? You guys were talking about sections 2.3 through 2.6, right? No, 2.3 through 2.5. Want to make sure I'm on the same page as everyone else. Cool. That is what we're going to talk about then. All right. Okie dokies. So, does anyone have any questions about that or not? If not, I'm just going to start right there at 2.3. All right, and let me see what page this is on the book. Sorry, I have an online copy of the book right now. So trying to figure out what exact page it is. All right, so it is page 140 that I'm on right now. All right, and okay. Let's just kind of start doing some problems. Let's do problem 4. So problem 4 says we need to take the derivative of g of x is equal to 7 over 4 x squared minus 3x plus 12. How am I going to take this derivative? Is this a product rule? Yep, it's just sums. So all we're going to do is we're going to take the derivative of this and bring it on down and add it to the derivative of this and the derivative of this. It's actually 12. So this is going to be 7 over 4 times 2x minus 3 plus 0, because the derivative of just any regular old number is going to be 0. So I'm going to rewrite this as 14 over 4x minus 3, or is that 7 over 2? And that's my answer. All right. Let's also do number 8. So what rule are we going to look at this with? One way to, a good way to start approaching these problems is take a look at the problem and kind of decide what method you want to use to solve it. And then try to solve it using that method. And if something goes horribly, horribly wrong, then you know that perhaps you chose the wrong method. So we have this function. How are we going to do this? There are Yes, there are two ways that we could do this. We could go ahead and use the product rule, but foiling it would be probably easier. So let's just do that. If we do the FOIL, then we have 3u squared minus u plus 6u minus 2. So it'll be 3u squared plus 5u minus 2. So h prime is going to be 6u plus 5. Everybody okay with that? Sweet. Okay. What about something like number 14? Sorry, my pen is not working as well. I don't know why that is. Come on. There we go. So number 14, we have y is equal to the cubed root of x times 2 plus x. Yeah, this is page 140. Sorry. We're just in section 2.3 right now. All right. First things first with this problem, what should we do? Yep, we can definitely do x to the 1/3, not 1/2, 1/3. And I actually probably wouldn't FOIL here, just because I don't like working with these fraction things, and I'm kind of weak on my exponent rules, but we can definitely do that. So that would be what, 2x to the 1/3 plus x to the 1/3 times x to the 1, so that is x to the 4/3, right? That's 3/3 plus 1/3. Yep. So this would be that, and then we would just take y prime, which would be 2 times 1/2 would be 1, so this would be x to the negative 1/2 plus 4/3 x to the 1/3. Yeah? Everybody okay with that? You want me to spell out that step faster? Okay, I'm going to spell out that. No, you're fine. Don't apologize. I am going to, okay. Isn't it 2 to the 1/3? Yes, you are right. See, this is why I told you I was weak on my rules of exponents sometimes. So what we have here is we have, this is wrong. That is Liv not knowing what they're talking about. So I'm going to rewrite this as y is equal to x to the 1/3 times 2 plus x, and I'm going to write to the 3/3 right here. Okay. You're right, and I got that 1/2 there. That's wrong too. Oofta. I just made a slew of mistakes in that one. Okay. So let's do this again, and let's do it slower. And I'm going to write everything out, so hopefully I can actually follow myself here. Okay. So that would be 2x to the 1/3 plus x to the 3/3. And then because we're multiplying, we would do to the 1/3. So what this is x to the 1/3 times x the 3/3. Right? Because we're multiplying, if we were adding them, then we would be able to, I don't know. Right? Okay. Everyone's saying yes. Then add the exponents. Yes. Yes. Okay. So this is 1 2x 1/3 plus. Yes. Yes. Okay. I'm sorry. I am so sorry. All right. So this is where we're sitting at right now. Then we're going to take the derivative of that. So that would be 2 times 1/3 x to the 1/3 minus 1 plus 4/3 x times 4/3 minus 1. And so I'm writing 1 out as 3/3. So this is going to be equal to 2/3 x to the negative 2/3 plus 4/3 x to the 3rd. And that should be the correct answer. I apologize for all the confusion that went on there. But everyone is okay with this? I didn't make any more stupid algebra mistakes? Yes, it is a-okay to have a negative exponent. Yeah, they can, I mean, like, maybe if you're doing a multiple choice exam, they might have this rewritten in a way that's a little bit different. Just be comfortable moving between forms. Like if this is 2/3, yeah. Do you want to do that right now? Yeah, okay. So that would be the cubed, that would be, this would be, I'm gonna move my chat box, sorry. So I have more room to do it over here. So, okay, so how I would do this is I would kind of separate it out while I think. Sorry, I'm trying to catch up with the chat box. How I would do it is separate it out like this. So it's 2/3 times x to the negative 2/3, and then I would just rewrite x to the negative 2/3. And then I would do the same thing over here because I don't really want to think about what's going on with that coefficient right now. That's not my priority. If I'm going to rewrite this, I'm going to say it's like 2/3 times 1/x to the 2/3 plus 4/3. And this would just be the cubed root of x. So I can have that be like, this is like fully simplified at this point. It could also, I guess, be written as 4 times the cubed root of x over 3. This, on the other hand, is going to be 2/3, and then this can be written as 1 over the cubed root of x squared. So this can then be written as 2/3 cubed root of x squared. Or as this, or as any of the steps in here. Awesome, good. So the answer could be in any one of these forms if it's on a multiple choice test. If you're just taking a regular like written exam, then this should be a fine answer because it's totally correct. All right. One sec, let me get resituated here. Gotta problems. All right, let us also, let's do problem 20. We're still on page 140. So problem 20 says g of t is equal to the square root of 5t plus the square root of 7 over t. Okay, so first things first, I'm going to put this in a form that I can work with a little bit better. Let me write this again. Okay. And now I can go ahead and use the sums and differences rule that we were using along with our power rules. So this is going to be, I don't know what is up with my tablet tonight. This is going to be 1/2. So that's going to be 7, and that's going to be a -1 times t to the -2. So this can be rewritten as square root of 5 over 2 t to the -1/2 minus, it's not a t, that's a 7, t to the -2. And then we can also rewrite it as this. Did I make any algebra mistakes that were stupid? Because that is the big point to fall on any of these is algebra mistakes. Because once you guys know these rules, you guys are golden. You just need to take it slow, write everything out, make sure that you're not losing yourself on the algebra. We looking good for this one? Ten minus 4? What is that? Oh, 10-4. Oh, it's been a long day. All right. Okay. Let's do some more. Let's do one that actually lets us use like the product rule or the quotient rule. So I'm going to clear this, and we're going to go ahead and do problem 22. Let's do 22. Okay. Where am I going to start? What am I going to do first? Any ideas? Yes, we are going to use the quotient rule. To start with, though, I'm going to simplify this denominator because that's not really, I want to like work with a form that I'm more familiar with. So 4t cubed is going to be 4t times 4t times 4t, or 4 cubed t cubed. 4 cubed is what? That's 16 times 3, that's 48, right? Yeah. So that would be 48. This is going to be d of t is equal to 1 plus 16t squared over 48t cubed. Okay, now I'm going to go ahead and identify which function is my f. So I'm going to have f of t be 1 plus 16t squared. I'm going to go ahead and define my f prime right now while I'm working with f, and so that's going to be 0, 0 plus 16 times 2t, or 32 t. Okay. Then I'm going to go ahead and do my g. That's 48t cubed. So my g prime is going to be, gosh, what is 48 times 3? 150, 144, right? Yeah, okay. All right. So I just went ahead and defined what all of that was to start off with. And now I'm going to go ahead and put it all together. So the quotient rule tells us we have f prime times g. So I'm going to go ahead and put f prime in here, which is 32t times g, which is 48t cubed, minus f 1 plus 16t squared times g prime, 144t squared. And that is all going to be over. No. As far as I know, you will not be given formula sheets for these particular, like any rules of differentiation you will be expected to remember. And that's another thing that practice kind of helps. Just kind of like getting into the groove of like, okay, this is the formula that I'm going to use. But so f of x and then f prime of x, not both g, bottom right, bottom left. What is the issue here? F of t, g of t, g prime of t. Oh, these are my f's. I'm sorry. This stuff in green is all f. My f's are like cursive f's. I will change that. So those were both f's. Okay, so let's finish this up. We have g squared. So that would be 48t cubed squared. Okay, now it's again a matter of algebra, simplifying all of that stuff. So you will be expected to do this on an exam without a calculator, but for the sake of just like time right now, I don't really want to do all of this multiplication by hand. So we're going to wrap this up by saying this is 1,536t to the 4 minus 144t squared plus 2,304 t to the 4 all over 2,304 t to the 4. Okay, so we'll simplify this a little bit more. I'm just going to distribute that minus sign. So I don't have to rewrite the whole thing. So that will be 2,304 minus that. So what we're going to be looking at is 768 t to the 4 minus 144 t squared all over 200 or 2,304 t. Let's factor out some stuff and see what we can factor out. So that's 16 times 48 t to the 4 minus 9t squared. Aha, you're right. You're right. This should be negative, and this should be to the 5. So did I do that right? Yeah. So this should be to the 5, but that is 2,304. Yes, 6. Sept. Aha. Algebra. What is algebra? Nobody knows. Actually, I specifically do not know. You guys seem to know. It's to the 6 because it's an exponent to another exponent. So we're going to multiply it. Yes. So this should be, as Adam pointed out, 2,304 t to the 6. And that is correct. This is going to be negative. I'm going to cancel out those 16s right there. So our final answer is going to look something along the lines of negative 48 minus, or t to the 4 minus 9t squared over 144 t to the 6. Yes, you could. Let's do that right now. T squared So our final answer will look something a little bit more like this, which is definitely more digestible than this mess up there. All right. That's one of the unfortunate things about the quotient rule, is that it gets pretty messy pretty quickly. But fortunately, we do get it to work out kind of nicely at the end of it all. All right. Does anyone have any specific questions about these types of problems? If not, we can move on to section 2.4 maybe. All right. Let me see if I can find 2.4. Sorry, I've got the PDF of the book, so it moves like very quickly, and I just skipped all the way to like chapter 5 accidentally, which is not where I would like to be right now. Okay, so 2.4, we're working with taking derivatives of trig functions. And this is another one of those things that you're just gonna like have to memorize, which is like really unfortunate. But that is just kind of how it works. Let's do problems. There are the problems. All right. So I am currently on, oh gosh, what page am I on? I'm on page 150. And this is section 2.4. And I'm going to start off by doing problem 2, where I have f of x is equal to x cos x plus 2 tan x. All right. First things first, what am I going to do? Okay. Yes. So we are going to use the sum rule. We could do it like that, but we do have a rule for finding the derivative of the tangent, don't we? Or am I just crazy? We do have a rule for finding the derivative of the tangent. Yeah. So it's the secant squared. If I could speak, that would be handy too. So first things first, I'm just going to bracket this off for right now because we're going to come back to that because we need to use the product rule to solve this. But we do know that the derivative of tangent is the secant squared x. So this will be 2 times secant squared x. So fortunately, we have a rule for that. Here, on the other hand, we're going to have to use the product rule, where we're not going to use f, we're going to use h, because I already have an f kind of in the mix right now. H of x is equal to x, h prime is equal to 1. G is equal to cos x, and g prime is going to be equal to negative sine x. So the derivative of x cos x will be equal to x times negative sine x plus 1 times cos x, or cos x minus x sine x. So I'm going to go ahead and put that in up here. F prime of x is equal to cos x minus x sine x plus 2 secant squared x. And that should be our answer. Don't make any mistakes along the way. Nobody's calling me out on any, so I think I didn't. But so I could explain the product formula of x cos x? Is that what you're asking? Okay. So here I just went ahead and instead of f of x, I just went ahead and said that the first one is going to be h of x. And that is going to be x. So I have h times g of x. And so the derivative of this is going to be equal to h prime g plus g prime h, right? That's how the product. Yes. The reason I didn't is because this is a constant. And these are separated by a plus sign, right? So what we did here, yes. So the 2 is a constant. It's just going to be the same. Here, let me separate this out. Sorry, I have a tendency to color code things so that I can kind of organize them better. So I'm going to kind of do that right now. Cos, okay, so let's divvy this up. Let's take a look at f of x really fast. So a number is a constant if it's not a variable of the function, right? So if I were to have something that looked like this, yes, 2 is a constant, x is not a constant. If I were to have the function f of x be cos x plus 2 tan x, b would be a constant here. It's not necessarily the fact that it's a letter, but it's the fact that it's not one of the things that is changing in the function. If we have a function f of x, it means that we're looking at the variations of x. And therefore, if x is hanging out, wherever x is, it can be changing and is a variable. So if we were trying to find the answer of x plus 2, this is still a function of x, right? So x is going to be the variable in this instance. So in the blue, this is a variable, and we are going to need to use product rule because we have 2 functions times one another. We have this h of x, which is my x, and then we have this g of x, which is my cos of x. And so those 2 are multiplied by one another, and therefore we need to use product rule. Here, it would just be negative b sine x, because this is a constant. If x changes, b does not change. Okay, so we're good with that? The reason I didn't include the 2 tan x is because when I went ahead and did this, I said, hey, I have to find what the derivative of this is, and then I need to add it to the derivative of this. Right? Yes, I think yes, if I understand what you're saying. So that is how the sum rule is explained, correct? We have the derivative of this plus the derivative of this is the derivative of the whole shebang together. So then what I did is I said, hey, in order to do this, I need to use the product rule. And I'm going to do that by saying this is going to be x prime cos x plus, here I'm going to call it plus cos x prime x. So that's my product rule, and that's the derivative of this one. So in order to find the derivative of this in particular, I use the product rule. I'm going to go ahead and put it down because I just solved that over on this left side of the board in like the peach color. So this is going to be cos x minus x sine x. Correct? Then I'm going to say I need to finish the derivative by finding out what the derivative of this is so that I can have the whole thing put together. And I went ahead and used my rules of taking derivatives here, and this is what I ended up with, the secant squared. And because 2 is a constant, not a variable, I can just keep it right in the front and use it as a constant. And I'm going to write that down as 2 secant squared x. And then I can take these brackets out because I'm not multiplying it by anything, just to like make it look a little better. Did that help clear things up for you guys? Okay. This is kind of an example of something that takes like a variety of rules to solve. You need to approach it from a variety of different steps. You need to take it one at a time if it's like a sum rule kind of like this. I remember my professor in 140 would basically like on like some of his homework problems and quizzes would see how many rules he could fit into a problem. Like exactly how much could he make us do in one problem. And it was very, very difficult because you had to sort through all of this material, but it was very helpful to like do problems that use multiple rules because then you kind of know how to approach them. So this is an example of one of those problems. Let's take a look at some others in this section. Let's do, oh, on a similar vein to this, we're not going to solve number 7. I just want to kind of show you number 7. Y is equal to c cos t plus t squared sine t. So, what is my variable? This is kind of what we were just talking about, t. Yep. So, is c a constant or a variable? Constant, yes. So the question is, why can we not just jump to the product rule? What do you mean by that? Yes. These, though, this is not a product with this, is it? So because these are not multiplied, we can't do a product rule because we're not taking the product of them. We're just taking the sum, so we can just use the sum rule. Let's see. We can like do a product rule with this constant, but the derivative of the constant is going to be 0. So we're going to start off with f times g prime, or negative c sine t plus 0 times cos t. So like we could take a product rule with c as one of the identities, but because c doesn't have a variable attached to it, it's easier just to consider it as part of the constant. Am I answering your question? Awesome. Okay, so we don't actually have to do that problem. I just wanted to point out that it's an example of one of those where we have a constant, and that constant in this case is c, but since our variable is t, c is still a constant. Okie dokies. Let's do number 10. So number 10 looks like y is equal to sine theta cosine theta. So what are we going to do with this? How are we going to solve this? How are we going to find y prime? Suggestions? This is a one-step process. It's a product rule, exactly. So we're going to start off with f of theta is equal to sine theta. So f prime is going to be cosine theta. And then we have g g of theta is equal to cos theta. So g prime theta is equal to negative sine theta. So we're going to put these together. We will end up with f times g prime, or sine theta times g prime negative sine theta, plus f prime cos theta times g. This will be cos theta. So we're going to simplify this all out into negative sine squared theta plus cos squared theta. Let's see. See, I don't think I can multiply this. I don't think it is -1. I don't think we can simplify this using trig identities any further, because we have that negative sign in front of the sign, right? So what this is not sine squared plus cos squared. It's cos squared minus sine squared, right? So that's not going to be simplified using trig identities. I mean, we could mess around with it, but this is a fine answer for our purposes. Because what? Sine squared. What would this be? Sine squared plus cos squared. So that would be 1 minus cos squared. So this would end up being cos squared theta minus 1 minus cos squared theta. So that's not going to simplify anything out. We're just going to end up with, oh yeah, no, it won't. We'll end up with 2. We'll end up with cos squared theta minus 1 plus cos squared theta, or 2 cos squared theta minus 1, right? Because we have to distribute that negative sign. So it's not going to simplify anything out to use trig identities at this point. You can, it's the same thing, but this is just easier because it's what you get to first. So yeah. All right. Let's do sorry, I gotta move my chat box and some of this space. Oh gosh, and I just lost my page. Darn it. Give me 1 sec to find where I am in the book again. Okay. Do you guys want to talk about the chain rule right now? We can kind of get some experience with everything talking about the chain rule. Awesome. The chain rule is really fun, guys. I really enjoy doing problems with the chain rule, mostly because I like writing things down. It's like really, okay, you got to get like a really good pen and then just like write everything down. And it's just very satisfying to like, I don't know, fill up a page with math. You feel very intelligent. Get a good pen. Okay, so the chain rule is cool and exciting. It is for composite functions. So a lot of the time, in my experience, people who are learning about the chain rule and the product rule simultaneously struggle with telling the two apart and like when they should do different things. Like, should I use the chain rule or should I use the product rule? The fortunate thing about it is that a lot of the time, like, at least for me, I have a tendency to like write everything out, and sometimes it like doesn't work quite right if you aren't doing the right one. So, priorities though is determining if it's a composite function. So let's start with what page am I on? I'm currently on page 158. Let's see, what would be fun to do? Let's do 10. All right. Okay, so let's identify what our functions are. What's my first function? There's two different ways you can really look at this. One is going from the inside out. So starting from this chunk in here and saying, this is my first function. And I'm going to call that H. Somebody just said something in the chat. What do you mean 2 minus x? Yes, yes. Okay. Yeah, okay. Like, we're on the same page. All right. So this first function, this bracketed part here in green, that is what I'm going to call my first function, the inside function. And I'm just going to go ahead and find the derivative for that right now. That's going to be negative cos x. And then I'm going to look at my outside function. I have a tendency to do it like this because it's kind of like chronological order for me. I start with my inside, I work my way to my outside. This is going to be my outside function, this part in particular. So if this is h of x, this part in green, then I'm going to go ahead and call this big pink thing, I'm going to call it, we're going to go with j. J of h. And I'm not going to use x here, actually. I'm going to say that it's j of h. And the reason I'm going to do that is because I don't want to get myself confused. J is going to be a function of H. Because J of H is going to be the H, and H is a function. H is H of X, but it is H to the 3 over 2. And so this is kind of how I'm going to tell myself I have a function within a function here. I'm not going to be using the chain rule, or I'm not going to be using the product rule. I am going to be using the chain rule. So I'm going to go ahead and find myself J prime, which is going to be 3 over 2 H of X to the 1/2. Correct? That's right. That's right. All right. So I have J and I have H. And I just kind of picked these arbitrarily because I already had G up here. And I like using different variables if I'm going to set up a problem like this. Does it make sense what I did? Separating it out by color, this inside function, this outside function, calling it J and H. Okay. As long as everybody's on the same page, then we can go forward. So I'm going to write down my rule for the chain rule. And the chain rule says something along these lines. If you have this function J of H of X, and you want to take its derivative, it's going to be, sorry, I'm trying to think back, which one is F and which one is G. It's going to be J prime of H of X times H prime of X. Correct? So what I need is I need J prime and I need H prime, both of which I have solved for up here. And then I also need H to kind of fill this out. That's kind of the difference between this and the product rule too, is because I don't actually need this to solve the problem. It's just one of the steps of getting to the point where I can solve the problem. So now that I have my formula kind of established, I'm going to fill in what I need. So J prime of H of X is 3 over 2 H of X to the 1/2. And then I'm going to multiply that by H of X prime. Or H prime of X, excuse me. And now I'm going to go ahead and sub in the stuff in green. Oh, that's prime. See, already I screwed up. I need the regular H of X right now. And now I can do H prime. All right, and I know that I'm sitting in a good place because the only variables I have right now in this whole equation are X. And that's what I want, because then I know that I'm on my way to finding an answer. So I'm going to simplify this out. I'm going to call this 3 over 2 times 2 minus sine. Actually, I'm going to call it negative 3 over 2 cos X times 2 minus sine X to the 1/2. So I just smushed it all together, multiplied it all together. I moved this out front, mostly because when I look at this, I like to see my exponents kind of at the end. But this is a perfectly acceptable answer here too. This is just kind of how I would write it. And then I would call that good. There's really nowhere to go from here because that would be the derivative. This is G prime. Did everybody follow what just happened? Do you want to try another one? Cool. Let's do, also, if anyone has a suggestion, feel free. Let's maybe do 24. Actually, let's do 16. It's page 158, I think. All right, so let's do 16. So 16 is going to be f of t is equal to t sine pi t. So what are my functions? This is actually like this. So yes, Alexander, yeah. Alexander got it. So it is going to be t, and we're going to call that h of t is equal to t. And then we're also going to have g t is equal to sine pi t. The reason I wanted to make that distinction is because somebody in the chat said t sine pi and t, and so I wasn't sure if they meant like divvying it up like this and then like that. But this, when it's together, it's going to stay together in those kind of parentheses, those hypothetical parentheses. You're not going to divvy it up like that. Does that make sense? Okay, cool. Okay, so we have h of t and we have g of t. What are we doing next? What equation am I putting this in? Yeah, Adam got it. It's a product rule problem. I'm putting this into the product rule. And kind of the way that I can tell that is because I was able to pick out two distinct functions. I have h prime is equal to 1, and I have a g prime, and this is not g of h, this is g of t. These are two functions multiplied by one another. So I did try to pull one over on you, and you guys did not fall for it. G prime of t is going to be pi cos pi t. And we are going to put these together just like we would with any product rule. It'll be h times g prime plus, whoa, my computer just yelled at me, times g plus g times h prime. Yep, so let's just go ahead and squish them together. That would be t. How is it pi cos pi t? Okay. Did you guys not? Okay, so if I have something on the inside here, actually, I don't remember any problems specifically like talking about this. If I have something on the inside here, I'm gonna pull it out when I take a derivative. So g prime of t, I'm gonna pull that pi out, and I'm gonna like make a copy of it and move it outside. Did you guys not talk about this? That's mildly distressing. That is actually mildly distressing. Okay. Okay, so I'm gonna just do a separate little problem here so that we can discuss that in a way that is not directly related to what this problem is right now. Okay. Say we have the function f of x is equal to. Did you cover like how to take the derivative of e to the 2x? This is a completely different order than what I'm used to. I'm sorry. I've been doing 110, and we approach it in a completely different order of how to do things. So, we are going to do we're going to do it like this. We're going to find the sign of you are going to cover e in the natural log. I haven't really looked ahead, but I would be floored if you guys did not. So I'm pretty sure you guys are going to cover e in the natural log derivative-wise. Okay. So the way that we take this derivative is actually a form of the chain rule, but we don't explicitly call it the chain rule really because it's like a way too complicated way to like go ahead and say, oh, it's like, okay, yes, Adam is right. Adam is right. The answer to this is going to be and the reason that we get there is through something that is akin to the chain rule, that is the chain rule. We're going to say that our first function is going to be h of x, and that is going to be 3x. So h prime is going to be 3, and then we are going to have the function g of h is going to be sine h, and then g prime of h is going to be cos h, correct? So we're going to put it all together and say what we have here is cos times h. Our original h is 3x times h prime, which is 3. So the answer is going to be 3 cos 3x. Did that make sense? That was just chain rule? Done at a very strange angle for some reason. Okay. The simple way of approaching this is going to be you can just bump this thing out. If I were to give you f is equal to cos 4x, then f prime is going to be equal to negative 4 sine 4x. You can just pop it on out, make a copy of it, move it out. I don't know. This is like a pretty standard type way to like approach a rule like this. So if I were to give you here is a little interesting forward lesson, I guess. If I were to give you f of x is equal to e to the x, then f prime is also equal to e to the x. So move the constant out, take the derivative of the function. Yes, exactly. So e to the x, the function is exactly the same when it's taken, you take the derivative of it. So if I were to give you y is equal to e to the 123x, then y prime is going to be equal to 123 e to the 123x. It's the same principle as this cos thing. If sine is squared and if cos is squared, I would walk through the whole chain rule, because here, I will just do that problem right now. If you have something that looks like this, you're going to need the chain rule for it. If you have y is equal to sine squared of, what's a fun number, 7x. What you're going to want to do is say that what this actually is sine of 7x squared, and then you're going to say f is equal to sine 7x, f prime is equal to, actually we're going to call this g prime is going to be equal to 7 cos x, 7 cos 7x, excuse me. See, I'm wrecked today. Correct? This is just what we talked about, bringing the 7 out there. We could do another round of the chain rule very explicitly, but we don't have to because it's pretty simple in terms of like this very specific moving that 7 on the outside. And then we're going to say that f is equal to g squared, and that f prime is equal to 2g. Correct? So if the sine is squared, or if it's cos squared, then you're going to have to use the chain rule anyway. And so what this is going to come out to be is 2 times sine 7x times 7 cos 7x, or 14 sine 7x cos 7x. Derivative. Did I mess something up? Okay. Cool. All right. Yeah, no problem. I don't know why they didn't tell you that explicitly. It seems like something that's pretty easy to just say. But yeah, if you forget, you can always just use the chain rule. And just like prove it to yourself very quickly. But yeah, so you can just bump it on the outside there, and that's how in whatever problem we were working on, we ended up with pi on the outside. It's also really interesting kind of to see how it kind of stacks. Because say you have y is equal to sine 2x, y prime is going to be equal to 2 cos x, or 2 cos 2x. When I'm going kind of fast, sometimes I leave it out. So it's a sign that I'm moving too fast right now. I'm thinking too fast. If I take another derivative, because you can take derivatives of derivatives. I don't know if you guys have kind of talked about second derivatives conceptually yet, but you can just take the derivative of that anyway. I mean, it's a function, isn't it? So y double prime is going to equal like 4, negative 4 sine 2x. And you can just kind of keep going, and this number will just keep getting bigger and bigger because you're never taking it out of here. So that was the little extra spiel for the day. I was wondering why I didn't see any e's in here, and I guess you will talk about that eventually, I'm sure. Okay, where were we? We were in problem 16, where we had f of t is equal to t sine pi t. We went ahead and said that there's one function that is equal to t, And then there's one function that is equal to sine pi t, which we now can take the derivative of. That's not sine, that's cosine. And we can put them together to end up with t, or pi t cos pi t plus sine pi t. And that will be our answer. For 16. Okay. 25 looks like a doozy. Who wants to do 25? All right, so 25 is going to be h of theta is equal to tan of theta squared sine theta. Yay. So what we have here is we're going to be using a couple of different strategies to solve this. First of all, let's break this into what we need. What is the first thing that we're going to kind of do to approach this? We have a we are going to need to use chain rule. Because what we have is a huge function thing here, right? And then another function on the outside. So this blue is a function of the slick peach. So I'm just going to go ahead and write this as, I'm going to just start with that. F of G is equal to tan of G. I'm just going to say F prime of G is equal to sec squared. And ouch. That hurt. Okay. Sec squared of G. Yeah. So what is G? G is going to be, it's going to be G of theta. Let's specify that right here. G of theta is going to be theta squared sine theta. Correct? So first things first here is we just kind of looked at the first thing, and we need to know what the grand overarching scheme of this is. So we found our chain rule. We have a function within a function. We're going to solve it using that chain rule method. Okay. Also, the only way that you can just like pop it out is if it's a constant. I don't know if I specified that like as explicitly as I probably should have, but if I were to have I don't really know. Okay. This popping out thing only works for constants. That's a constant thing only when you do it that quickly. If you were to have x squared in here, I would go through and just do the whole chain rule. Just do the whole thing. Because that would make your life just not necessarily easier, but more explicit. And you would know exactly what's going on. Okay, so we know we have a chain rule going on. Let's just try to solve this. We need G prime of theta. And we've hit a roadblock because we need to use the product rule to solve this. So if I have G of theta is equal to theta squared sine theta, what I'm going to need to do is say I have J of theta is equal to theta squared. J prime is equal to 2 theta. Yes, Adam got it. And then we have k of theta, which is equal to sine theta. K prime is going to be cos. So we just did this exactly like we would any product rule problem. We figured out exactly what this is. We're going to put it all together. We're going to say that this is theta squared times cos theta plus sine theta times 2 theta. And I'm going to simplify that into g prime of theta is equal to theta squared cos theta plus, there's nothing to simplify. I don't know why I said simplify. I'm just going to kind of rearrange it and put it in blue. So now I know what my g prime is. And I'm going to use that to solve this problem. So I know that what this is going to look like is f prime of g times g prime. So f prime of g is going to be secant squared of g, and g is going to be theta squared sine theta. This is our original g here. And then I'm going to multiply it by g prime, which is going to be this long thing that we just figured out using the product rule. So my final answer is going to be h prime of theta is equal to, oh, and this is in brackets here. And I'm just going to kind of leave them bracketed off because I don't really want to distribute right now. Seems a little unnecessary. So that's my answer. And I had to use both the product rule and the chain rule to get it. Did that make sense to everybody? Awesome. Okay. Yep, nesting. That's a good way of describing it. Nesting in there. All right. Does anyone have any questions? We've been at this for about an hour and a half, so it's probably about time to call it a night. But if anyone has anything they'd like to talk about, feel free to ask. Yeah, for sure. Yes. The question we just had was, is this the case? And the answer to that question is yes. If you want to think about it in a little bit of a different way, you can just imagine this being -1 times sine x. And so this would be a constant. And so this would be -1 and then the times the derivative of sine x, or -1 times cos x. Yes. So that negative sign, if you ever see a negative sign just kind of hanging out here, you can always separate it off and say that's -1, and I'm not going to worry about it until the very end because that's a constant. So if you're going to take Yes. So an example was just brought up in the chat. If you have negative secant x, f prime is going to be, one way that you can like think about this is -1 times secant x. So f prime is going to be -1 times the derivative of secant x, and that is going to be -1 times secant x tan x, or negative sec x tan x. Yep. It's always absolutely fine if you want to simplify things, or not necessarily simplify. Sometimes it is making it a little bit more complicated, but write very explicitly what's happening. I do that a lot to keep track of my work, and you'll notice that the minute I try to skip a step and like do it in my head, I make a ton of mistakes. That whole shindig we did at the beginning where I had no idea what was going on was because I skipped a bunch of steps in my head because I thought I was a big fancy math dude. And I guess that wasn't the case. So write everything down, at least for me, that really helps. All right, any other questions? Oh, thank you. All right, no more questions. I hope you guys all have a great night. Feel free to email me if you have any questions like in the week that you want to cover in like the weekend session. And I will be sure to write that down and chat about it. All right. Y'all have a great evening.